Two, one, and we are live. Hey, everybody, and welcome to another network session with Corco. Today, we have a very special event in collaboration with Decentralized Technologies. But before we get there, I just want to remind you that this is your last week to apply to our QA testing program. So if you have basic knowledge in Java and if you can hold a conversation in English, you can join the program to get ready to land your dream job at a software company. So apply now, the link's below. Or we're going to put it below. So thank you for joining. Now I'm going to be passing the mic to Rafa so he can introduce himself and so he can also introduce us to the main dish of the night.
Thank you, Sofia. My name is Rafa Cordon. I founded a company called Decentralized Technologies, or DT for short. We basically built an application called Simple ICO. It's a decentralized application where anybody can go online at simpleico.com and create their own token for free. I've been working in the blockchain space for maybe like 4 years, and I'm really excited to hear this talk. I have the honor of presenting Cody Marx Bailey. Cody is a real pioneer in blockchain, and Cody has contributed to projects that define the underlying protocols for blockchain. So it's a real honor to have Cody talk to us about blockchain.
Welcome, Cody.
Yeah, thank you. I appreciate the opportunity to do this. Sofia and Rafael, y'all both been good friends to me over the last few years as I've been exploring y'all's beautiful country in partnership with UFM and different organizations, DT and all you guys. Rafa, I was on a podcast with you guys about, 2 years ago or a year and a half ago?
Yeah.
It was a lot of fun.
That's awesome. Cool. So before we start the presentation, I just want to remind everyone that's watching us that you can write any comment, any question on the link on it's possibly here or here. It's on the chat. So we're going to be bringing your questions to the conversation after Cody is done with his presentation. And without further ado, me and Rafa are going to leave, and we're going to leave you with Cody, and see you soon.
All right. So this is mainly going to be a technical talk about Ethereum, which is the platform that I'm the most familiar with and have the most experience with. So I don't want to get into things like, Bitcoin pricing or what's going on in the economics side of all of this. I'd really kind of like to keep this more of a technical talk. So yeah, let's dive right in. So the first thing, if we're talking about Ethereum, which is a specific type of blockchain, we need to talk about what a blockchain is. And humorously, you can say that a blockchain is simply a chain of blocks, which is kind of a funny way of saying it. But basically, you have it looks a lot like a database, and you have updates of what's going on per transaction cycle. And we'll get into all of these terms in a little bit. This is a very complex system that I'm going to have to put together, but we're going to do it in kind of bite-sized chunks. And then at the very end, I'm hopefully going to stitch everything together so that we can understand exactly how all these things work. So let's talk about complex systems. So I like to use an analogy here of an internal combustion engine, which is the type of engine that our parents used, but we're trying to get away from. And if you look at an engine inside of a car or truck, you'll see that there's a lot of different pieces in there. It's a very complex system. You've got everything from spark plugs to vacuum hoses to camshafts to alternators, cooling fans, all these different pieces. And if you go back into the turn of the century, the 1900s, each of these individual systems, a water pump, a spark plug, a piston, each of these were being sort of developed and perfected to a point that they could be depended on to be used together. So you can think of just a pump, operating by itself, or a camshaft, or any of these pieces. But only whenever you were to put all of them together, then you got a new higher level of order. And that's a really important piece here. So a quick overview. So Ethereum is a complex stack of mature technologies, and that's going to go into the timing of when blockchain was possible. The concepts and the theory and the philosophy of what a blockchain is and could be were actually talked a lot about in the 60s, 70s, and 80s. Almost 30, 40 years ago, 50 years ago in some cases. And the problem was that the water pump and the pistons and the camshaft weren't quite ready to be used together. We didn't have the understanding or the refinement of those pieces of technology to combine them. So another key component to blockchain is it's immutable through robust consensus. And I'll talk about what consensus is and why that is so important. It's secured by proven encryption methods, and that's a little easier to talk about, and we'll go over that in a little bit. And the real magic behind blockchain, the part that's really exciting about this, is that it yields no central authority or entity. This is a distributed system that's not controlled by any one member, person, company, government, or anything. So that's a really important piece here because it's something that the world has never had before. So let's talk about Ethereum. So Ethereum is what's considered a second generation blockchain. And if you compare it to something like Bitcoin, Bitcoin is sort of the very first blockchain that worked or that was viable. The recipe kind of made sense and everything was tuned, correctly so that it stood the test of time. Ethereum is that second generation. Once we learned how Bitcoin worked, we thought, let's make this a little more advanced. Let's improve upon it and kind of come up with a second generation. And Ethereum so far, after 6 or 7 years of it being in deployment, looks to be working fairly well. In fact, it's working too well in a lot of ways, but I'll get to that later. So the components here that I'm going to try to explain one by one are the network, which is the communication layer, the ledger and database, which is what makes up the actual blocks in blockchain, smart contracts, which is the real important piece to make this a second generation blockchain. Smart contracts are really what allow us to do some really, really creative things with these blockchains and really make them more than just a simple store of value like Bitcoin. And I don't mean to keep talking negatively about Bitcoin. It's just that Bitcoin is a very, very simple and elegant blockchain or solution, whereas Ethereum gets much more complex. But as complexity happens, you get more opportunity. And then the security and trust. That's another really important piece on how all these things kind of fit together. And the glue that holds all of these four pieces together is economic incentives and game theory. These are the parts that kind of make everything work together in a really clever way. So, like I promised, we'll talk about the Ethereum network. So we're talking about a peer-to-peer network, what each node in the network, which member of the network, what their responsibilities are, and then how the network can perform against attacks and different attack vectors. So getting into that. So peer-to-peer networks, we've seen these over the last 30 or 40 years. These networks sort of, the concepts and the way that we design these networks over the last 30 or 40 years. In fact, the place where we really started to see some real adoption and production from these peer-to-peer networks was through the BitTorrent network. You had enough people wanting to download the latest Marvel film that the engineering behind that, the people that were responsible for creating those things, really had an incentive because they wanted to download a Marvel movie, built these networks and really perfected the science behind them. You get geometrical scale efficiencies, and then let me explain what that means. So if each peer, each node in the network, call it a computer, connects to 25 other computers, and then those 25 are connected to 25, after 4 hops, so just 3 generations later, you're able to reach 390,000 computers within a second. If you think about how latency works across the network, and that was a real important piece, the latency thing. So BitTorrent really took off around 1999, 2000 timeframe, and that was when we started having cable modems and actual bandwidth inside the home, where we had enough stability and speed, latency on the network that we can then sort of create these bigger mesh networks, these peer-to-peer networks. So this is a little older of a map here. These numbers are probably need to be updated, but as of about a year ago, there were 6,065 nodes on the Ethereum network. And you can see that there's sort of it looks like America, is United States is way ahead, and they are a little bit, but if you look at the total number, it's only 30% of the network. The rest of it, the other 70%, is distributed around the world. China, Western Europe, and then parts of Latin America, of course. And so, so this kind of gives you, this is a global network. This is a worldwide network. This is not something that's necessarily dominated by one country or another. You know, even though the United States seems to be leading in this chart, that's only 30%. So keep that in mind. There's another 70% that exists outside of that jurisdiction. So we're going to get into Ledger. This is talking about the blocks in the database level. So how this thing works. So like I promised you, a blockchain is simply a chain of blocks. Each block references the block before it, thus creating a sequential chain of compiled updates. When I say a block, that is imagine a file or a chunk of data that is standalone. And what it does is it references the one previous. So you have these like sort of chunks of data, and they reference each other. So if you have, you know, say the newest block is block number 7, it references number 6, 6 references 5, so that you can chain these things together in some sort of order. Now, I need to address something. I'm making this very, very simple. There is a lot of complexities behind each of these topics. So when I say that one block simply references the one before that, it's a little more complicated than that. There are some things around hashing that allow these things to sort of lock in, and the further back you go, the harder it is to change, based on these consensus models that I'll talk about in a little while. But if things are getting a little fuzzy through here, just hold on to the very end, because I've got a really important slide that connects all the dots. And so the idea behind these chain of blocks is that you can go through time and see the updates one by one. In fact, if you go to Etherscan, which is the premier block tracker, you can go through and inspect and look. It's open source. This is all open to the public. You can see exactly what was happening on each block, every transaction, everything that changed between each period of time that each block represents, which is roughly 14.5 seconds. So I'm going to get into what this table looks like. And as you can see, I'm just kidding. We're not going to get that deep. But that is a diagram of an Ethereum block. Like I said, when I say one block represents the one before it, there's a lot that goes into that. So we'll move on. Smart contracts. This is the part that really got, I think, a lot of computer scientists excited about this, where once they had sort of digested what Bitcoin can do, and they said, oh, that's pretty simple. It's a really elegant but very simple to understand system. When smart contracts came out, this is where sort of the floodgates of creativity opened. And this is where we're seeing more development, more interesting things, more new ideas being expressed, really in the world of computer science than really anywhere else out there. So smart contracts, they're little programs. They're fairly simple at this point. And they are autonomous. So these things are executed by the chain. And you're probably asking, well, what is a chain and how does it execute something? And we'll get to that in a little while. But basically, this network, this peer-to-peer network of all the different nodes, are executing these contracts on your behalf to exercise some sort of yield or some sort of result based on the inputs from users. And again, this will all make sense at the end, I hope. So disintermediation, these smart contracts allow us to basically get rid of a lot of the middlemen in society. So between the consumer and the producer, you might have several middlemen or intermediate steps that serve as either trust agents or downstream providers for things like purchasing without a merchant, betting without a bookie, insuring without an underwriter, loaning without a bank, which is a really interesting piece there. So how do you loan money if there's no one there to loan you the money? How does that actually happen? And there's some interesting ways that we can talk about that later if we have time. Trade stocks without a broker, escrow without an agent, establish an uncensored internet without ISPs. And the last one there is, I kind of tacked that on. That's a really interesting area that's being worked on right now, where we're getting rid of these middlemen that mark things up for no reason. It makes a much more efficient market. It makes for a much more less friction between the value creator and the value receiver. So now we got to get into currency and economics, and this is where things get kind of where the glue between all these things. How we harmonize everything so that all the different people that are involved in these networks have aligned incentives and they work together to create something really beautiful. So the economic model, in order, and I'm going to read from this a little bit, but to build a global computer, you have to have an economic model to prevent abuse. To operate the computer, you must spend a cryptocurrency native to Ethereum called Ether. This is specific to the Ethereum chain. So other chains use their own currencies. There's a restricted amount of Ether, thus creating a scarcity model that helps throttle and provide incentives for the miners. And I'll get to what a miner is in just a second, although I'm pretty sure most people on this have probably heard of what a miner is. So, like I said, we'll get into mining. So I'm going to talk about what it is, what proof of work is, the gamification and incentives, and then the network verification. We're starting to pull things together here. So these are this first sentence. It took me a while to come up with it, and it's very, very dense, but it describes exactly what's going on with mining. It's the gamified process of incentivizing participation in a decentralized system to achieve consensus. I know that's a lot of words, big words and big concepts that are kind of thrown together, but I'll explain what they mean. In short, without a centralized authority or trusted source to provide a random winner, we need to simulate or gamify this process. And what we're looking for is we're looking for a rotating member of this mining group or this peer-to-peer network to become the authority to make a decision. But if there's no centralized authority, how do you randomly select somebody? You can't just say to one of the other people, hey, it's your turn, pick a random number, and they pick their friend. That would be, there's no way to really get around that. So this is accomplished through a system known as proof of work. And this is kind of the piece that really, this is sort of the last domino we needed. We needed to solve this one piece in order to make really any blockchain system that uses proof of work to actually function. So when the previous block was created, a very difficult mathematical puzzle is posed to the network through an algorithm inside the protocol. And this is what's called a one-way cryptographic function. So typically if you have a function or a mathematical equation and you multiply, divide, add, and subtract, well, to undo that, you could just add, subtract, divide, multiply, and kind of work your way backwards. But with a one-way function, that's not possible. There's some really interesting pieces here, and really core concepts to cryptography that really make this these concepts are part and parcel to how cryptography works. It's this entire idea that you can do a one-way function, but you can't go backwards. So it basically allows you to create a secret and then a publicly known information. And I'll get to that in a second. So the idea here is that you have a needle in a haystack, right? So there's a way of running these one-way functions where it basically poses a number, and then you have to go and run a computer to do many millions and billions and trillions of calculations to find a matching number inside this infinite number of numbers that are out there. And so the idea here is that you would have multiple miners coming in to basically trying to look for this number. And the person who has a faster computer may have a better chance of finding that number. And then once once one of these members of the network, one of these nodes, finds the answer, they say essentially, I found it, and all the rest of the people in the room are like, oh, I didn't find it. So that's how consensus is built in the middle. This is a very, very difficult concept to sort of understand initially, but I think we'll see what happens on the next slide. And I think this will put it all together. So like I said, every 14.5 seconds, a new block is created. And this is the complete block cycle. This has been going on every 14.5 seconds, roughly, for the past 7 years without fault. This is really cool. So the previous block is mined. The miners begin a new challenge, right? They start looking for that needle in a haystack. They're spending a lot of electricity, a lot of money, a lot of electricity, a lot of time, and a lot of effort to find this matching number, right? Meanwhile, users are submitting transactions to the mempool. So this is individual users, could be me, could be you, could be a corporation, could be anything, could be a group of users. And what they're doing is they're trying to either send value or operate a smart contract or execute something inside the Ethereum blockchain. A single miner finds the solution. I found it, right? That person spent, maybe 10 seconds, maybe 20 seconds. It's tuned to be an average. They find a solution and they say, okay, I'm the winner of this round, bingo. Then they take transactions, which you see on the top right. They take some of those transactions, award themselves 2 Ether. That's the reward. And right now, Ethereum is worth about $1,700. So you're looking at about $3,400. That's the bounty of basically playing this game with the other miners. If you can find the number faster than the other people, then you get a reward more often. They author the new block. They pose it to the network. The network then makes sure that everything that they put into that block is correct, and all the signatures match up, and we start the cycle over again. And like I said, this has been going on for 7 years, every 14.5 seconds, without fault. There have been attacks. There have been times when things got interesting, but really the system has worked very well from the beginning. That being said, I guess it's time for Q&A now. Glad to answer any questions you might have about how this stuff works. Some of these things I've been working with for literally 20 years, 25 years. So sometimes I go through these things a little quicker because it's something that's just obvious to me, but it may not be to you. So I'd be glad to answer any questions y'all might have.
Well, thank you, Cody. So I have a question.
Sure.
This whole DeFi thing that's being mentioned, like in the news and all. Can you talk a little bit about that? I know it sounds sort of like a marketing term, but I think there's some very important changes behind that.
Yeah, so I actually gave a talk about a month ago on DeFi. And so DeFi is just a term to describe a set of technologies. It's not a company. It's just like the word blockchain or internet or car. It's not a company. It's not, it's just a term to describe certain things. So DeFi is a term that describes a set of technologies that is aiming to replace all of the core pieces of the financial system, the global financial system, on blockchain. So when we say disintermediate, we're not just talking about like adding some small things here and there. We're talking about replacing entire markets, marketplaces, stock exchanges, commodities, loans, derivatives, equities, everything. So really, it's just the beginning. It's just the beginning. So when those are some really ambitious hopes, I guess. But there were a few of us back in the early 1990s when our JPEGs would load like this. Remember JPEGs when they would images that would just slowly. I might be or dating myself here, but there was a time when that happened, and some of us saw that and went, if we just keep improving this technology, we keep refining it, if we keep adding, we keep at it, man, one day maybe our JPEGs will load like that. Or maybe it'll be 2020 and we stream Game of Thrones in 4K in our car. See how far we've come. So if you told somebody that in the early 90s, like, well, yeah, one day we'll have a screen, that we'll be able to watch movies on in our car. They say, well, your JPEGs only load like this and you have a modem that's screaming at you. Give it time. These technologies are very young. One day, the Model T will turn into a Ferrari. So in that DeFi space, that's where a lot of the work is happening right now, because these tools, what blockchain allows us to do is really attack those sectors. Just like with, when the internet was first being introduced to society, it was a communications tool. So we need to figure out how we can send video, how we can do video chats, and what we're doing today, it was really a communications tool. So, when the dust settled and you understood, we looked back on, what problem did the internet solve? Well, it solved the communications problem. It didn't solve the banking problem. It didn't solve it created e-commerce because we could communicate, but it didn't, it affected a lot of different things because communication is key in a lot of different areas. But blockchain in particular, the ability to remove trust agents, to disintermediate entire areas, the financial industry is the target for these technologies. Rafa, I like the smile. You're like, yeah.
No, I totally agree with you. And there are projects right now that are applying this. So like Uniswap is, I think, the most prominent one. Can you talk a little bit about current projects that you see that are challenging traditional ways of doing things?
Yeah, I've got one so I'll cover Uniswap real fast just because you mentioned it, and Uniswap is the sort of the darling and the first big um, utility launched in that space that's kind of got the spotlight on it. So Uniswap is a really cool set of smart contracts that are not owned by anybody or owned by any company. Uniswap is an organization and they have their own business model outside of this. But what Uniswap is in utility is a way for users to basically trade tokens or trade stores of value. That could be tokens that represent ownership in gold, ownership in a company, US dollars, Guatemalan quetzales, like any number of things out there that you wanted to represent. And so you can bring those two people together, and then without having a middleman or someone to support in the middle, can basically swap those tokens one for one in sort of what we call an atomic swap, which means that I'm not having to release my tokens until they release theirs, and then it happens at the same time. So there's no chance of like, well, you pull your money out first, and then no, you do, and there's not that sort of standoff between the two parties. So that's a really interesting one, and there's also a liquidity provider behind that, which allows for instant transactions. There's always a buyer and always a seller available. Maybe not for the price you want, but it's always there, and that really helps with speed and getting these transactions done. Mm-hmm. And that's only going to grow in size and scope as more people, sort of leave the old world and sort of join the new world.
I have a question there. Or are you going to elaborate more on that?
No, not on Uniswap. I was going to move into a different tool, but yeah.
Oh, go ahead.
Okay, so this is a project that I'm working on that I'm really excited about, and I think, I'm not a lawyer, and thank God, and I'm going to make some assumptions here that it might be difficult for people in Guatemala to participate in the U.S. stock market or in the U.S. financial system. There's all kinds of barriers, for a good reason. As an American, there's reasons why our government may not want outside people kind of playing in our value system. I get that, but there's a lot of pent up demand right now. So if you go to Brazil or India or any developing nation, or really any nation in the world, let's not just talk about the developing nations, but really everywhere from Germany to Japan to Mexico, where I live, you have a lot of people that have this demand for U.S. investments. Well, there's a really interesting system called Mirror Protocol that I'll talk about here, and it's something that I caught about a month and a half ago, and it's been really on my mind since. And what we're able to do is basically create synthetic, as in not real. These are not real equities. These are not stocks. What they are is they're an asset that reflects the price of the stock market. So now all of a sudden you've created an asset out here on the blockchain that anybody can have access to, that gives them price exposure to U.S. or to any equity out there, any derivative, any index fund, really any financial tool out there. So make no mistake, you're not getting access. You're not a partial owner in Google or Tesla or whatever stock you want, or index fund or whatever you want. You're not getting ownership of that. You're simply getting an asset that is price correlated to that. So it's essentially the same thing. You're not going to get dividends. You're not going to get earnings calls. You're not going to get all the nice benefits of owning a stock, but you're going to get price exposure, which is probably 95% of the value of actually owning a stock. So now we're opening up the entire world to price exposure to the U.S. stock market. What is that going to do? Well, we're going to find out in the next 2 years, because this stuff is growing. It's growing fast. We're seeing money come in places and allowing some really innovative and beautiful things to happen right now. So unlocking value across borders. Sophia, go ahead. What's your question?
Sure. Now I have, before I do mine, I'm going to use one of the participants because I think it relates to what you just mentioned.
Cool.
Alcides is asking, what do you think you can do better in technology in other areas in the world? I'm guessing he or she, I'm not sure but I'm guessing they're referring to which other applications blockchain may have to improve the state of the world.
Sure. So we're in the middle of a pandemic. Hopefully the only pandemic of our lives. And governments have been put in a real tough situation. Some of them deliberately, or just from the government doing what they do best, which is screw things up. And And I don't know if y'all know this, but like, the U.S. government has produced 35% of all dollars ever created were created last year. So you have a monetary supply that is ever growing, and which creates inflation. So that value is no longer protected by the people, but by the people who control the printing press, the people who can print up money, the guys in Washington. So all of a sudden, the dollar that I had yesterday is worth less today than it was yesterday. To no fault of mine. My work was still good, but that's the sort of thing that we're looking at. So a lot of governments in the U.S., because it's the world reserve currency, there's a little bit of leeway that can go there. But if you're in a developing nation like somewhere in Africa, and all of a sudden the government says, well, we have a lot of debt, we'll just print up some more money, right? We'll just print up money. We'll just keep printing it. And there's the old saying. Yeah, it's like there's an old saying about, why doesn't the U.S. government just print up $1 million and give everybody $1 million so we're all rich? That's not the way it works. Like, you can't just give everybody money and all of a sudden it's worth something. So it's that scarcity model that they keep messing with. What we're able to do is rip that control back out of their hands, put it in the control of a computer system that's managed by millions of people around the world who have a vested interest in not creating more supply than there is demand. And so what that does is it creates a higher value. So when you look at that thing, and I hate talking about price, but when you talk about the rest of the world, that's the place that it liberates people from their governments of having to depend on them for their currencies. And this is something that, since the moment we were born, everybody in this chat, since the moment we were born, we just thought, well, there's US dollars, there's euros, there's quetzales, there's pesos, and that's just the way the world works. So it's really difficult for us to sort of reprogram ourselves to think like, is there an alternative currency? Like, or what the hell is an alternative currency? Like, how do you even start with that? These are the exciting questions that we're having to ask ourselves. This gets very philosophical. This is, Rafa, I know you know this deep inside and out, but this gets deeply philosophical and deeply, you start, once you go down these roads and you see how these systems can be built and what they can do, you start questioning the role of almost every piece of society. It cracks the foundation a little bit, and you start to kind of dream. So, yeah.
I think everybody has this this like matrix pill moment. When like for me, it happened in 2017 when I was like, oh my God, what this thing can change the world.
Yeah.
And at that moment, like I can't stop thinking about it.
Yeah. And it's a drug, man. You get addicted to it. You look at like the old world, and you're like, why would I ever want to go have a normal job again? Like I just can't do that. So yeah.
And I love it. And on that line, Isaias has a comment, and I think that brings on a question, because he's mentioning, looks like we're going back to free markets with every individual being able to create their own blockchain coin to exchange services. But then Gabriel comments on Isaias, probably, but I think that it would be naive to believe that banks aren't going to readapt their practices in the future to include this technology in the commercial bank system. So I think the question that arises here is, do you really believe that the middleman can disappear, or will the middleman become like friends with blockchain? Can that happen?
So I think I love using analogies because it's easier to look back in the past instead of trying to like imagine the future. So I don't have the answer for banks. I have like some ideas, and it'll take us, 10, 15 years for us to finally realize what the winners were, what banks made the right decisions moving forward and which ones didn't, and so I think looking backwards is a little easier. So when the internet came out, there was this whole idea of like, email, and maybe one day you could get your news on the internet. Like you could download a thing called a web page, and it would have like the news on it. And I remember showing like my parents this, back in the day, and it showed, I showed them that, and they thought, well, I can just get the paper down, on the front porch. Why do I have to come in here and sit down at a desk and see this stuff? And what happened was, and we all saw the demise of things like, Blockbuster Video, which is you go get a tape or a CD and take it home and then return it, and you had to burn fossil fuels to go back and forth to deliver this data, or newspapers and stuff like that, which have all turned digital. It's very difficult to transition from an old industry like that to a new industry. And we're seeing, some of them made it, but I mean, how many media companies fell over the last 20 years? I think that's the real key piece. for the second part. The first part, though, going back to the everybody creating their own currency, it's difficult to get people to agree on what has value. So in that regard, we can look at something like gold, and I'm going to use an analogy here between gold and Ethereum. Or I'm sorry, gold and oil. Okay, so gold, the element, and oil, the lubricant, and hydrocarbon. And I'm going to relate those back to Bitcoin and Ethereum. So let's ask, what gives gold its value? So gold's value comes from the market. People agree that gold has a certain value. Gold is worth, $1,800 an ounce or whatever it is right now. And so if you don't believe that it's worth that, I'll take it off your hands. If you have any gold and you don't believe it's worth $1,800 a gram or an ounce, I'll buy it. I'll take all of it, right? But no one's going to do that because it's worth $1,800, and there's someone that's willing to buy it. So just for the same reason, I can't go outside and pick up a handful of dirt and say this is worth $1,800 because no one's willing to buy a handful of dirt for $1,800. So gold is also protected by the ability for us to create more gold or mine for more gold. It's not like tomorrow. There's roughly $7 trillion worth of gold in existence, and it's not like tomorrow we're going to find a piece of gold the size of the building that I'm in. We're not going to flood the market with gold because it's really hard to find. It's pretty scarce. Like, you have to dig a lot of dirt out of the ground to find gold. On top of that, what prevents gold from us creating gold is the atomic structure of gold itself, the actual atomic bond of the atom. So if you were able to create gold, which we can do with high amounts of energy, we can actually fuse atoms in the right way to create a gold atom. But it costs more than it's worth. So you'd end up spending $10,000 to create an ounce when you could just buy it for $1,800. So that's what protects the value. All right, what gives oil value? Well, it's not because it's scarce. I mean, you have to dig it out of the ground, but you can pull up a lot of it pretty easily, especially in parts of the world. But it's not scarcity necessarily that gives oil its value. It's because you can make fertilizers, you can create fuel out of that. It burns. If you look at the downstream products that are made from hydrocarbons, from oil, it's amazing. So that's what gives oil its actual value. If we got rid of all that stuff, and I came to you with a cup full, a glass full of oil, and said, hey, this is worth something, you go, why? What am I going to use it for? It's the utility. Mm. So that's something that gold doesn't have. Now, you can make jewelry out of gold and stuff like that, but the real value is in scarcity. So let's apply those back to Bitcoin and Ethereum now. Bitcoin is a lot like gold. There's only 21 million that will ever be created. We're at roughly 17.5 million. So we're almost to the end of the supply. And there's a vested interest in every person that owns Bitcoin to not create more than that 21 million. So you have a massive network of people who all agree we are not making more than 21 million. And it's in everybody's best interest to not create any more, because otherwise the price would go down. So everybody's incentives are aligned now to create some sort of scarcity. So really with Bitcoin, what makes it valuable are a lot of the same things that gold makes valuable. Okay, moving to Ethereum. Why is this Ethereum, why is it worth something? Well, that's what you use to incentivize the miners, remember the network of people who run the blockchain, to settle transactions, to do work for you, to execute those programs, and to build trust in what you and the other person are doing, to serve as the intermediary. That's not a company, that's not, that's not that provides any friction between the two parties. So that's a really great analogy to take away from here, is that Bitcoin is a lot like gold, Ethereum is a lot like oil. I think that's a really great thing to take away from here.
On the question of banks, maybe I think banks have two different functions. One is storing money, and the other one is assessing risk and pricing risk. On the pricing risk piece, I don't know what do you think about that, Cody? That's still a skill that will be needed, regardless of currencies.
That's correct. But do we need someone to come in and do that for a premium? So what is the actual cost? So let's talk about an escrow. I'll make it very easy instead of getting into complex loans and packaging loans together and spreading risk and diversifying. With an escrow, let's say I want to buy a home from Rafa. Rafa has this beautiful home and I want to purchase it. Well, Rafa's like, I've got the keys, and I'm like, yeah, well, I've got the money, right? So how are we gonna do this trade-off with, hey, meet me in a parking lot with bags of cash? Well, we're gonna go to a bank, and what I'm gonna do is when I put the money into the bank, so the bank holds it on behalf of Rafa, they'll release the keys to me. And that's really what an escrow system does. But really, the bank might end up charging 1, maybe 2, sometimes 3% on an escrow, simply to verify that the keys were given to the right person. Okay, was the value 3% of a home to make sure that like this condition was met so that the keys could be released? Like, do we really need to be paying? Like, think about the inflated price of your home now, right? Because we had a price at 3% more to do this silly thing with the key. I mean, escrows can be in larger transactions, the premium goes down. But what if we put that whole system on a blockchain, right? Now, my analogy probably doesn't work very well with a physical key, but if you have these escrows for any number of conditions to be met, maybe payout, maybe if you complete some work for me, I'll release payment. Well, if the blockchain can sort of settle that for us, the amount of electricity needed to basically flip a bit from a no to a yes to release the funds is less than a cent, it's nothing. So now we've all of a sudden taken 3% of the transaction fee down to 1 cent. I mean, we can do escrows all over the place for everything. We can inject these into even the smallest values of transfer. You buy a pizza and there's a need for an escrow for some sort of a trust to be built. Cost us less than a cent. Let's do that. Ensure the transaction. So I think that's the key piece there. And there's a lot of services that banks provide, loans and stuff like that. But even then, if you can create the system that overrides what they're doing and all the human injection into the system, and sometimes it's even monopolistic. The government forces you to use these people, and they're saying, yeah, well, you know what, you have to use me to do this, under compliance. So the government and the banks are, I don't know if any of y'all know that, but the banks and the government are sort of working together. You're familiar with that? Okay. Yeah. So just think about how we can get rid of this stuff. Like, we're fixing problems here.
Super, super interesting. Now I have this question from Byron. Byron Lopez is asking, could you recommend a book or a course to get started in blockchain? And I think alongside that question, I would like to ask if there are like any background skills that you would suggest people to have before entering the blockchain world, like any development thing or any mathematical economics. What would you recommend?
So in order to get to start working in blockchain, you really need to have a super core understanding of the base pieces, the blocks, so to speak, of how this thing works. So you probably wouldn't want to come in and just assume a certain thing and try to jump in head first. You kind of have to understand how the underlying system works, why transactions take time, some of the issues and just areas you need to really be familiar with the entire system. So a person that I would suggest is a guy named Andreas Antonopoulos. If you we'll send out a link or get that information to you of his name. But he does some really great talks, and he's written a book called, I think is it Mastering Bitcoin? Is that the?
I think so, yeah.
Yeah, Rob, I know. Yeah, it's out there. It's his bestseller on Amazon. But that's a really good one to start with. And if you're a developer, if you're a programmer, if you're someone that likes dealing with logic and stuff, we're not using languages like JavaScript or Python or really any sort of well-developed languages. We're using very, very basic and very, very incomplete languages because this is such a new area. So imagine going back into the 1960s. Like, you're not going to have all these, fancy objects and libraries because the computers weren't very fast. Well, that's kind of what we're dealing with today. The Ethereum blockchain is just not capable of running super complex algorithms, super complex things. It's doing very, very small things, just like computers did in the early 60s. So I think going back and understanding very simple languages. So the language that we mostly program is one called Solidity. And it's actually a fun language to program, but it's, you know, if you're wanting to do for loops and wanting to do like maps and arrays and like do some really exotic stuff, not the right place to go. You got to think much simpler and much more, you know, you're paying per operation. So you really got to be efficient. You really, and if you're dealing with money, you can't have any bugs at all, period. If you have a bug in your thing, your money's gone. And if you want to build an application that the world's going to use and you're handling potentially billions of dollars, that's a lot of money to lose if you make a mistake. So yeah, it's not like slinging code in web browsers.
Awesome. So I'm gonna put the link in the description after the session, but thanks for your question.
Yeah.
I'm checking the comments.
So another question, you were mentioning transaction costs, Cody. So like if we go to current issues with Ethereum, transaction costs are through the roof right now.
Yep.
Do you think that has to do with a gas limit, or is there a solution to reduce transaction costs?
Yeah, there is. There's a lot of opinions here. So, boy, there's no like simple answer to anything to any of these questions. Right now we have we're sort of really every viable blockchain right now is a victim of its own success. So because everybody's trying to use Ethereum at the same time, you have to have some sort of a seesaw effect of supply and demand. And because of the limits of network connectivity, peer-to-peer networks, everything we're trying to achieve, what we built only scales so much. And so now you've got sort of a clogged system. You have more demand than the system can actually service. That's what drives the cost up. And so there are a lot of competing theories or opinions on how to solve that problem. There's creating what's called layer 2 solutions. Things there's off things that can be done off chain. How much of this stuff can we still get done and not break the core philosophical system, but still maintain outputs and production basically. So some interesting things out there. There's one in particular called Avalanche that I'm watching. There's another group called Matic that I think just got renamed to Polygon. The layer 2 solutions are what's sort of hot right now because we really can't make a whole lot of changes to the Ethereum, like layer 1, the original Ethereum, just because this global machine is kind of hard to upgrade. You break a lot of things and you're kind of stuck with the design decisions you made 8 years ago. So that's where we're looking at right now. So the nice thing is that you have sort of an evolutionary biological approach to how these things change. You're seeing different opinions duke it out in the marketplace, and the users, we're the ones that make the decision. We're the ones that make natural selection. We pick the winners and losers based on economics. What saves me money? What's the most efficient? What's the fastest? And we'll find out a winner in a few years as these things sort of duke it out and fight. It's a really great process, but this is kind of like how open source software works. It's like a bunch of people get together and decide one opinion is better than the other, and they fight and see which one wins, and that yields the better product. So it's really great. It's a really fun time to be alive.
And you have forks with people that don't agree.
Yeah, and that's great. Forks are great. And a fork basically means that you have a set of chains, a set of blocks that are chained up, and then all of a sudden you get to a point where everybody says, well, we think we should change these parameters, and another group says, well, we disagree with you. And if there's enough people, let's say it's 60-40 or 70-30 or 80-20%, there's enough people on the dissenting view that they kind of go off on their own and see who's right. Let's see who wins. In the case of Ethereum, we have Ethereum and Ethereum Classic. And with Bitcoin, you have Bitcoin Cash, Bitcoin SV, you have Bitcoin Diamond, Bitcoin Dark, Bitcoin. There's been a lot of forks on Bitcoin. It's a very opinionated, highly contested area. But really, when you look at all of the different chains that are out there, Ethereum has the most developers. It has the most support. It has everybody's in the same boat. Everybody sort of agrees. And when there's a disagreement and a potential fork, cooler heads prevail, and the community says, okay, I may not be happy with it, but to preserve value and to keep moving forward, which is the goal, let's not argue. We'll just go that way, and I'll say I told you so in 6 months.
I have a question. I'm curious because right now you're talking as if like people actually like hanged out in a video call and be like, oh no, I disagree with you. But how does that like disagreement work? Where do you guys communicate, or how does that work?
So yeah, so it's it depends on which group you're talking about, but really the blockchain community and ecosystem is so large that it depends on where you're talking about. If you want to go to like the very core pieces, that's usually done, you know, on things like everything from Telegram, which is kind of a funny place to do it. If it's got more governance, it may happen on something like GitHub, where you have like open access to a, you know, GitHub's not open source, but it's open enough, and we all kind of agree that it's got benefits. And then really, if you want to get into like hardcore governance stuff, we put a lot of the governance on the chain. So it's like, you know, say the three of us need to make a decision because we're, you know, the three of us are going to be deciding something. We'll have a vote online, and each of us can vote only once. Well, 2 out of 3 wins the election essentially. So but the thing is you don't want, like, there's a philosophy of open source where you don't want things hidden. You don't want to go into a closed room, right? Send the smoke out the chimney and then say we've chosen a new pope. How did you do that? Like, you're dealing with, the thing is, you're dealing with my money. Like, I have a vested interest in this thing. I'd like to see why you're making these decisions, and perhaps get in there and lobby for one, or add information, or add, you know, more opinions to these things to make a better decision. That's what yields better systems.
Do you think that's similar to like how a democracy works, or do you think there's a difference?
Yeah, in theory, that's how it's supposed to work. But then you get clumps of power like the media and different groups that collude and lie and to be honest, you know, our governments have gotten so sophisticated, especially in modern times, that it's really difficult for the average democratic voter to like be able to track all this stuff. You know, and it gets way too sophisticated, and you know, I think we're seeing that right now. But you know, transparency and open records, these are all things that'll definitely help moving forward. So this is really a power to the people movement. You know, people individuals in society being able to sort of bring that power back to us and say, hey, government, I want to see the records of everything you're spending. Every time you print up money, I want to see it. You know, I mean, imagine how much corruption. Power corrupts absolutely. That's, and we all know that. Especially living in Latin America, I've seen my fair share of it.
There's this quote by Buckminster Fuller that says, don't try to change, it's something like, don't try to change a system by building a new one, make it obsolete, or something like that. Right?
You gotta, it takes radical, because these things these systems of democracy get rooted into society so deeply that it's really hard to pull out. You almost have to go through and just break the system.
What are the last things that I'd like to pick your brain on, Cody? So what do you see in the future? What are the things that, you know, if you try to, you know, squint your eyes and see, okay, 10 years in the future, where are we going to see blockchains? What kind of applications can we envision?
Boy, that's
internet with no IP provider, like
and it aligns with the question of Freddy. Maybe think 20 years ahead.
Yeah, geez, guys. Okay, so you would think that with as much knowledge as I have about blockchain, it'd be really easy for me to say, like, rattle off 5 or 6 ideas. To be honest, right now, there's so much potential in so many areas. It's really difficult to project that far. I think we'll see. I think the area that I work in is financial services. So I think we're going to see stores of value, you know, remittances. Just, I mean, that's a very small part of blockchain, but a very large part of society in a lot of countries.
Guatemalan economy.
Yeah, I mean, half of Guatemala's imports are money coming in the country is from remittances from the United States. So I mean, if you can affect that by 1 or 2%, I mean, that's a massive amount. I mean, that's a massive amount by itself. I mean, think of how much value is being released back into the world and not harbored by the gatekeepers. So that's one area. I think breaking monopolies. I think breaking sort of the gatekeepers on a lot of different areas, having a lot more truth and a lot more virtue. I mean, just a lot more virtue in really any area. Like I said earlier, you know, when we look back at the internet, we think, what problem did it solve? Well, it solved the communications problem. Well, when you look, I think in 20 years, when you look back and you think, well, you know, once the dust settles and these systems are all fully integrated, what problem did we solve? And that was the trust problem. You know, and it's really hard for us to think about, like, what are you talking about? There's a trust problem? Like, yeah, you can't do business with anybody out here without insurance, without having some sort of provider in between you and the other person. Every time you swipe your Visa or MasterCard, you're basically having an intermediary come into that transaction and say, for 3%, sometimes more, we're going to basically offload the risk. But now the merchant is only getting 97% of what they were charging for. That's like, can we get around that? That's 3% of every transaction with a credit card. Now, granted, in Latin America, I know there's a lot of cash only, right? And that's because they don't want to pay the 3%. That means a lot. That could be, you know, pretty sizable part of the margins. But now you've got people walking around with cash in their pockets that can be mugged. Like, we need to solve this problem at both ends, and you know, not have grandma with, like, you know, boxes of cash under her mattress. Like,
that loses its value.
It loses its value, yeah, and it loses its value, and it's susceptible to fire or theft or any number of things. So, I mean, it's really hard to look that far down the road. I hate to be that person, because it sounds like that'd be a really exciting, like, forecast, but.
No, and it's cool. Maybe we have another question by Seth. He's asking if you think that governments and universities are going to stop using supercomputers, I think that's the translation, and are going to use blockchain to solve their computational problems.
If it makes economic sense, they will. But however, there's you know, if you're just doing computations for, like, let's say weather forecasting, which is really not, there's no national security, there's no, like, secrets with that. It's really just trying to maintain, like, making sense of the world for logistics and any number of things. Forecasting, that I can see it being distributed if it makes economic sense. So, you know, when I go to sleep at night, obviously I don't leave my computer, you know, it's not doing anything, I'm not using it. Well, that's a resource that we can then turn into something that can be commoditized and rented out. So in that regard, absolutely. If you're doing, you know, nuclear bomb simulations, or, like, you know, risk assessment on arms, you know, races around the world, and, like, you know, defense problems, like, that stuff can probably not be distributed out. They will need supercomputers for that. It just depends on a number of things. The data set that's needed. If it's a massive data set, you know, several terabytes worth, it's gonna be really hard to move that across the wire, you know, over the internet to each node. But if it can be chopped up into small pieces, then sure, why not? It can be commoditized. But I think high performance computing is going to be around for a long time, because you do have data sets that are you know, terabytes and petabytes worth that you have to have on premise and with quick access.
Like training machine learning models and things like that probably don't require blockchain.
Yeah.
Yeah, and that was a question that I had, because I was having a conversation with a friend, and he was like, blockchain is not really necessary. Like, there are other solutions that can also put aside the middleman. Do you think there is such a thing as other alternatives to blockchain to get to that same objective?
In practice, yes, but the incentives don't align. So the problem there is, yeah, you can create a intermediate for transacting value, call it PayPal, but PayPal has to make money because they have stockholders. They're a publicly traded company. They have employees. They've got insurance. They've got some building in San Jose. They've got all this overhead they've got to do just for you and I to transact value. So yeah, there are systems out there that provide the same function, but can never compete on price. And at the end of the day, price is king in every situation. Economics is the study of people's decision making based on their best interests. So if you can provide something with the exact same functionality as PayPal, but it's free, or the cost is 1/100th of what PayPal charges, then why wouldn't you want to use that system? So that's and we all trust PayPal because they're a big enough company and it's in their best interest to be a trust broker, but they charge us 2%.
Mm. Okay. I have another question about miners, and I think that's going to be one of the last questions before we wrap this up.
Sure.
But like, can you elaborate more on how, like miners? Are they like actually people who are called miners and who are actually doing the work to mine the thing? Because I think that's a concept that like.
Sure, we call it mining because you're searching for coins is like the idea behind that, which is a really bad explanation. But when you say a miner, that is it could be a group, could be a company, could be some friends, could be somebody in their dorm room, could be Rafa. He's probably got a miner somewhere in his house, I'm sure, maybe an old one that he's not using anymore. But what a miner is, it's somebody or some group or some entity that is responsible for a group of very specialized computers that are doing this very, very, very specialized math. And in fact, those machines are so efficient with doing their math that they can run an extremely high amount of energy through those machines, which costs money, right? So you're having to spend your own money to sort of play this game, to look for this needle in a haystack, which is what the miners are doing. And that miner is basically in a competition against the other miners to see who can solve the problem first. And so if I have 10 miners, which if you look up, like go on Google and just search for Bitcoin miner and just look at the images, you'll see like an individual machine, looks kind of like a shoebox with 2 giant fans on the ends. Inside are like hundreds of very, very specialized chips. These aren't computers like we would think, like a desktop, like a gaming rig, or even a laptop. These things are super specific. They're called ASICs, Application Specific Integrated Circuit. And so look at that and you'll start to get an idea of the size. Now, right now with Bitcoin, each block, so every 10 minutes with Bitcoin, you have a new block. The incentive for that is 6.25 Bitcoin per block. 6.25 Bitcoin is worth approximately 300,000. So a house is like pretty much like spit out every 10 minutes. Think about the competition for that sort of reward every 10 minutes. So that's where you get into some really, really fun math on how do you find out who the next winner is. It's like some people have built massive, massive warehouses full of these machines, hundreds of thousands of dollars a month to play this sort of lottery.
And are there like necessary technical efforts from that type of people, or is it just like investing in the machine and letting it to do the work, or do they need like a background on something, or could it be just anyone who wants to buy those types of machines?
So if you wanted to play with Bitcoin, like you could go out and spend a couple of $100, $300 or $400 on a machine that's going to sit there in your room. It's going to heat your whole house up. It's actually kind of nice. Like in the wintertime, it's actually a good source of heat. But they're very loud, and only one of these things, it'll probably take you 15 to 20 years for it to actually find. On average, that's on average. It take you 40, it could take you 50, but you're going to be spending a lot of money each month keeping that thing running. So with Bitcoin, it's not really it's not very easy to get into Bitcoin mining. But if you go find one of the smaller chains where there's not as much competition, and maybe you're going to find a solution or win that lottery every 2 weeks, and you get rewarded with like maybe $50 worth of something, that's a little more approachable. So most of the Bitcoin miners right now have spent upwards of $50 million on their facilities. So the competition there is very, very fierce, and it takes economies of scale to really participate.
It's an interesting lottery. Cool.
Can be lucrative, yeah.
Do you have one?
I did back in 2015, 2016, but I got out of that and decided it was a race to the bottom. It's buying a bunch of, some friends of mine and I were doing a mining operation, and I was up at like midnight poking holes in the wall for ventilation to get more cool air in. It was not what I wanted to do.
Cool.
I think every old school Bitcoin and blockchain person has tried to mine.
Oh yeah.
Have you tried, Rafa?
Yeah, we did with GPUs a machine with the guys at the office. Everybody pitched in some money, and we built a machine with GPUs. We were mining Zcash.
Yeah.
Back in the
day. Did you quit it, or do you still have it?
Yeah, it's sitting somewhere. That machine is done.
It's very, very interesting because I think sometimes we ignore like everything that's going on in the ecosystem of blockchain. Like usually we're just hearing like, yeah, blockchain, like, yeah, Bitcoin, but actually it's a lot of like work from people with their own incentives. It's very interesting to know that like one can actually learn how to be part of these types of ecosystems. And I think right now with what Cody has been sharing and what Rafa has been adding to the conversation, well, we've had this like brief but good taste of how blockchain works. And if anybody wants to keep learning, well, we're going to leave some resources. But I think we're coming to the wrap up time. I don't know if Rafa has any other question, like closing question that you would like to ask Cody.
What are you going to be working on in the next 6 months? Can we know?
Good question.
Yeah, so I'm working a lot in the financial space, looking for opportunities to create new financial instruments in blockchain that haven't been created yet. That requires a little bit of innovation, but really it's looking over your shoulder and seeing like, hey, what was developed back in the 60s in in the financial industry, and how can we recreate that here? How do we learn from those lessons? There's no sense in us going out and trying to learn the same thing that was learned, hell, even 80 years ago. It's not like a stock market's anything new. So that's a massive industry. We have a lot to learn. Programmers, coders, right? We have a lot to learn from the finance guys. So right now it's brushing up on finance and figuring out how these models work. And then once you find something that's sort of the right time at the right place, develop that, launch it, and see if it takes off.
Awesome. Cool work. So now what we do at the end of our network session is we ask both Cody and Rafa to tell us like a last message to the world. Like if they knew they had the opportunity to get to someone right now and help them change their lives for better, what would you guys say?
Rafa, you want to say it together?
No.
You go ahead.
All right. I'll say this: buy Bitcoin. That's the even if all you can afford is 500 quetzales or 1,000 quetzales or whatever you have, buy a little bit of it. It's a finite supply, and in 20 years you'll look back and think, I'm really glad I bought it on that day and not 10 years later.
Cool. And before we hear Rafa, I just want to tell like the people who are watching us, because I've seen some questions in the comments, that we're going to be adding some resources on the description. If Cody can or Rafa have any resources on how to buy Bitcoin or anything, we're going to be putting them on the description. So don't worry about that. We're going to give you that information later. And now I'm going to pass the mic on to Rafa so we can hear your last message to the universe.
As Cody said, learn and get involved. And in this game, to get involved, the first step is to invest or save some of your money in Bitcoin. This is a new world. We're at the beginning of the internet in terms of how blockchain is developing. I think there's going to be a lot of new things coming out, as you heard from this talk. And so please start learning. There's going to be a lot of, and we hope we in Guatemala, we can be pioneers in this space in the future.
I love those messages. And I also love them because I'm remembering that when I first heard of Bitcoin, I don't know if it was Cody, it was probably Cody, but it was someone and they were just like, can I give you $1 but in Bitcoin? And I'm like, what? Why would I like, okay. And then they made me like download the app. I downloaded the wallet, blockchain.com. And I downloaded it and they passed me $1 and then they were like, pass it on. And I was like, okay, I'll do it. Like we're spreading the word. And then next time that I saw someone, I already had like $3. And then I was like, do you want $1 in Bitcoin? And then it was cool because it just multiplied. It was very amazing. That was like 4 years ago. And yeah, it's insane how it's grown. So
there's a good analogy here where it's like someone's telling you like, hey, go out and get a good Gmail address, right? So you're not having to be like Cody Bailey 1275 or like I had to misspell my name because I didn't get there. Like this is the time to do that. Go reserve your chunk and stake your claim.
That's a great analogy. It's a great analogy. So okay, everybody, thank you for coming with us. It was a very, very nice conversation. It was super enriching. Let's all get into blockchain stuff, Bitcoin stuff. It's gonna be huge, apparently. And let's keep learning. Last thing, remember that you can, this is apart from this talk, but remember that you can always apply to our QA testing program on the link below, and we'll keep learning. And this would be it. Goodbye, everybody.
Bye.